So I'm Josh Rogers. I'm the technical trainer, one of the technical trainers at Power One. I joined the company 6 months ago after almost 9 years in the Navy nuclear program. I was an operator and instructor for the program there. Got into the renewable energy segment because I believe in renewable energy, and Power One, definitely a great company. Just in the 6 months that I've been there, have changed everything from operations to quality to their technical support, and everything is definitely moving in a positive direction. So today we're going to go over our products, mainly single phase and our string products. We're going to touch on a lot of material pretty quickly. We have roughly a little over an hour, so we're going to try to hit on some of this, get pretty technical into some of the wiring, the configurations that are available in our inverters. And you're going to see the design flexibility as well as some of the innovative technology advances over some of our competitors as well. So we're going to talk about the micro. We're going to talk about our single-phase string inverters, transformerless, and also our isolated inverters, which have the transformers in them. Also, we're going to talk about the installation, configuration, and maintenance. So we'll continue on. A little bit about our product portfolio. We're a unique company in the fact that we go all the way from 250 all the way up to 3 megawatts. So very small all the way up to very large utility scale projects. Ultra turnkey solution for utility scale, micro, all the way down to your modular level monitoring and individual panel solutions. Has anybody in here ever installed Power One string inverters? You guys, anyone familiar with Power One? Okay. Number of you. You're probably most familiar with our PVI series. These are our single-phase string inverters, our residential products. The newer, sleeker design is what you're going to see in our Uno 2.0 future product, the Uno 7.6 and 8.6, and the Trio has more of a sleek design. Like I said, the cooling capabilities and fins of the casing have definitely changed. So we'll talk about that a little bit more once we get into it. So our residential products, I already talked about the different sizes that we're going to go over. We'll talk about our isolated with the transformers, and then also our transformerless, and then our Uno, which is our single Mppt. So we'll get into that a little bit later. So first off with the micro, we got 250 and 300 watt models when it comes to the micro inverter. High frequency isolated transformers, so these use 18 kilohertz transformers. Electrolytic free capacitors. So big thing about electrolytic free capacitors is that they don't necessarily are impacted nearly as much by thermal changes. Another big thing about these is the input surges. They won't be damaged right away. So, if you do have an extreme input surge on the DC side, it doesn't kill the inverter. Same way with on our string line. If you have an install where it's wired improperly, in series, vice, and parallel, possibly overload the input. So that'll protect our inverters and allows for that. It's also wireless communication. So that's another thing that's a little bit different than something that you might have been used to, micros in the past. These wireless communications do not use power line communications, so you use radio frequency. So some of the key specs with our microinverter, I want you to definitely notice the operating input range, 12 volts all the way up to 60 volts DC. So you're going to get that maximum energy harvest, and that allows you for that higher power production. Mppt range, 25 to 60 or 30 to 60 depending on the model. Also, you got your max input voltage. They'll operate all the way up to 65 volts DC. After that, they're going to shut off to protect the inverter.
Is this on or off grid stuff?
This is on grid, correct. Okay. All of our invert. Yeah. What's that?
You need an AC signal to make it work.
Exactly. Yep. All of our inverters are grid tie inverters. We currently just partnered with Panasonic for possibly storage solutions in the future, but right now we have only grid tie inverters. The rated output voltage, 208 or 240 volts AC. So with the 208, you can accomplish possibly a three-phase system utilizing that voltage. Efficiency, we like to brag about our efficiency. Almost across the board, we lead the industry in efficiency. So we definitely like to point that out. Also, NEMA 4X, that's going to also be true across the board when it comes to our inverters. True outdoor environmental protection, completely enclosed inverters, so definitely rugged. And another thing is cooling. We use natural convection. We don't require cooling fans. We'll hit that a little bit more in our string products. Key advantages, I've already hit some of these. Our algorithm, Mppt, our maximum power point tracking, definitely one of the best in the industry. Our CEC efficiency, I've already talked about the electrolytic-free capacitors that are definitely very robust and help with the reliability of this product. Also, we got the simple AC trunk solution that I'll pass around a little bit later when we talk about it, and the wireless monitoring solution, and obviously with the micros, you're getting that individual panel monitoring as well. So, just to point out, one of the things that's great about 250 or 300 watt microinverters is that they have the capability of accommodating a 72 or a 96 cell PV panel. Not a lot of competitors out there, not a lot of products out there support these larger modules yet. So this is definitely one of those things that in design flexibility, you'll see across the board with our products, you have so much flexibility on what to do and how they interact. Another little product comparison, it's just showing you our wide DC input voltage range. It's going to highlight the fact that we allow you to have an extreme advantage as far as energy harvest when it comes to power production. Also the efficiency. So when it comes to shading, that's where the microinverter, being able to operate all the way down to 12 volts DC is huge, right? Once again, I'm going to reiterate the maximum energy harvest. You get a little bit of shading, it's going to knock out some of our competitors. They're not going to be able to produce once that shading kicks some of those diodes into bypass. However, with our micro, being able to operate all the way down to 12 volts DC, you get quite a bit of shading on that panel, you're still producing. You're still getting production out of that panel, even in what we would like to consider higher shading conditions. So that's definitely another way to maximize that production, especially if you're getting areas that have shading, and that's what you're using the micro for. So the system components, we got the microinverter. Like I said, there's two different models that you could choose from, the 250 or the 300. You got the Aurora concentrator data device, commonly referred to as a data logger or the CDD. It's wireless communications. That'll actually connect to your internet. You can either hardwire or wireless to your internet. And then it's radio frequency communications with all the microinverters as well. You also have AC trunk cable plug caps. All of those are for the connections that you're not necessarily using on the trunk cable. If you had any sort of obstructions on the roof that you were working around, possibly a chimney and whatnot. You also have the AC trunk end caps. Those are for the ends of each of your runs of cable. Then you have the unlock tool. So that's how you'll unlock all of these Amphenol connectors. Does anybody have any questions so far? We're moving kind of quick. Go ahead, sir.
Yeah, we're talking about DC input switch. What would be the cause of a short or something?
A DC input, not necessarily a short. You could get possibly like in the morning, very cold temperatures. You could get high voltages right on that initial sunlight, depending on the panel location.
Even
Question.
on the, like when cloud coverage is moving, the edge of the cloud, for some reason, really amplifies the radiance coming in, so you kind of shoot right into your.
Is that problematic with other products of this type? Do other companies have problems with that, or is that just something you offer in this?
I don't necessarily have information for that. I could find out possibly for you, but I'm not sure if it's a common issue. You might want to talk to guys at Rexel and see if they've found out.
If these handle the voltage down to 12 volt, they're still actually work, and other products don't work at that low voltage?
Right, so once the diodes get into bypass, those other microinverters will not supply power. They're going to stop production once those diodes go into bypass. So depending on the shading, also location of shading is going to depend on whether those diodes get, so that's definitely going to impact that. Being able to operate all the way down to 12 volts is definitely going to be on the power production side and energy harvest an advantage. Yep. Exactly. Exactly. Any other questions before we move on? Like I said, we're moving pretty quick. We're going to try to hit a lot of information. So the AC cabling solution, you got the drop cable from the microinverter. That's what's actually going to connect to your AC trunk cable. You have the AC trunk cable. This is going to be huge when you're ordering it and designing the system. Make sure that you pay attention to the cable pitch. This is going to be based on the size of the panels and the orientation of the panels, because ordering this trunk cable is going to be based off of that. Ordering the wrong cable is obviously going to be problematic when you get to the installation phase if you ordered the wrong trunk cable. So you have the drop cable, like I said, that's what's going to connect into the AC trunk cable. Right here you have your DC connections, your positive and negative connections for your PV panel. You also have your grounding screw. Probably a question that some of you might have: are we in the process of getting approved with Weebs, or are we approved with Weebs? It's actually in the testing phase with Burndy right now, so that will be an option available hopefully very soon. And it is UL listed. And this AC trunk cable, it's 10 gauge, 4-wire, 10 gauge, so very robust cable. So the portrait orientation, this is just showing you the different sizes that we have with the AC trunk cable. Once again, that's going to be important in the ordering phase and design phase. Landscape orientation, so once again, depending on the installation, you're going to have different sizes based on the size of the module, right? So that's going to be one thing that you're going to want to definitely highlight as far as ordering the AC trunk cable. So frequently asked questions. Some of you are probably already wondering, well, how many can I put on one of these trunk cables? How many of these inverters can I run on a string? Well, I'll give you a little bit of an example. Very common 20 amp breaker. For the 250, you can get 13 on there based on the amperage. And for the 240 volts, you can get up to 15. That 15 actually works out well with our CDD, which I'll talk about later. It does have limitations on how many microinverters it can communicate with. So that 15 number does match up kind of well with a 30 limitation on that. We'll talk about that a little bit later. So some of these graphics, they usually have a little bit of animation with them, depending on the computer that you're using. So this is just showing you the high design flexibility, either portrait or landscape. So it was going to go through and show you the different orientations. Question?
Is Power One doing any aspects with panels or module manufacturers with integrated?
Essentially make it kind of like an AC module. Not at this point, so I can look into that and see if they're considering it, but like I said, I haven't heard anything to this point. Any other questions before we move on? All right, so a little bit of the plant installation overview. These are some of the components that we already discussed. You guys got the trunk cable going around. If you notice, the trunk cable actually comes with a temporary waterproof cap. Actually comes with a temporary waterproof cap. So when you get this trunk cable, you can lay it out on your racking system, get everything set up, install the microinverters, and maybe come back the next day and install the panels. It also has a waterproof cap that you can get to put on there. This actually snaps in. This is more for long term. You're going to put that on there maybe because there's not a micro or a module on that portion of the cabling. So that's also available. Then you have these end waterproof caps. Those were going around as well in that pack of all the different plug connections and different wiring solutions that we have. So you're going to want to fix the micros on the racking system. It is very compatible with all the racking systems out there. Thing to keep in mind, once again, is going to be that cable pitch in between each of the micros and in between each of your panels. Secure the T-junctions with cable ties. There's little molds that fit those pretty well. Some people are concerned about using zip ties under panels, not necessarily seeing direct sunlight. They should be all right for that. Also, fix the end waterproof cap where needed, so on the end of each string or run of cable. You can go ahead and put those ends there. They actually have dedicated ports for each of the wires, obviously, to keep that separation. Then you're going to align the mating connectors and join the mating parts. So that's when you're going to actually install these microinverters, attach them to the AC trunk cable down here. And then you can run your grounding wires. So we'll look at a little bit as far as the different options for grounding. I did already discuss that we're in the process of getting approved for use with the weaves. But if you're using wiring, you can use 6-gauge, run a ground wire the whole way, all the way down to your ground, or you can ground it to the racking system if that racking system obviously can accommodate that. You can use 8-gauge as well for that.
Doesn't have to be continuous grain.
You get the continuous ground from the racking system.
From the rack.
Yep. Any other questions before we move on? All right. So once you get the plant installed, as you're installing it, as you noticed the micro circulating around here, in the little plastic bag there's another sticker with a barcode and MAC address. What you're going to do with that is you're going to place that on the map to map out the system. This is going to be important for troubleshooting, maybe later on identifying panels or micros that need to be addressed for certain issues. This also will come into play when you're setting up the monitoring tool on the website. You can actually configure the microinverters to look like it does on your homeowner's roof. That way you can see the shading throughout the day, see which panels are producing, which ones aren't. So it's definitely... Here's a little mounting example, a little obstruction possibly in the middle of the roof. That's that cap cover that I was talking about, the more robust, waterproof, permanent solution that you would want to put on there, not the temporary one that comes on the trunk cable. Then you got these end caps, like I said, on those end runs. Then you got these Splice Kits. You could consider using those instead of junction boxes to possibly simplify your installation a little bit, and then you'll run that to your service entry. Here's what one of those UF Splice Kits looks like. They're pretty simple, pretty easy to get. Slide a little cover over them, use a heat gun, or some waterproof electrical tape and get that sealed off. Clean, sleek install. It eliminates some of those junction boxes you might have to throw on the roof or around your installation. So once again, this a graphic that usually runs through what we discussed. It shows you them laying down the racking. It'll show them putting down the cable, different plug caps, and then the modules at the very end, connecting all that stuff. And this is available on our website, so if you did want to see this video, since it's not working today, you would be more than welcome to do that. So we do use Amphenol connectors. Some of the questions behind that are, what about Tyco, what about Tyco or MC4? Well, MC4 and Amphenol are both verified for TUV compatible. And with the Tyco, these aren't UL compliant with chassis mount solutions, so they're not necessarily meeting the code anyway. And I've already discussed that we're in the process of listing with Weebs, so that'll also help out with that installation when it comes to grounding. Question?
Weebs. I'm not familiar with the acronym.
Okay, so Weebs, I'm not sure what the acronym actually stands for. They're little metal connectors that you use for grounding. It actually mounts right to the racking system. So it essentially takes out that wiring, and you have a grounding conductor that's essentially a connector that is in between the microinverter and the racking system. So I can get you some information and show you what one of those looks like after the presentation if you would like that. Any other questions before we move on? All right, some of these accessories that we have and what you can order them in. This is a lot of information. Obviously, your distributor is going to have this information. But some of the things I just like to point out is the trunk end caps. You also got the plug caps. You're going to want to keep that in mind because depending on your install, you might have a number of end caps or weather caps that you're going to have to install. So keeping that in mind. And then the trunk spool, all that's going to depend on the landscape and the actual dimensions of the install. So the communication system overview. Anybody have any questions on the hardware portion of it prior to continuing on? We're going to get into the communications part. Communications, you got your microinverter. Use radio frequency to communicate with the Aurora CDD or concentrator data device. That you can go through the internet, and that can speak to Aurora Vision. Has anyone in here actually used Aurora Vision before? Patrick touched on that it's our monitoring solution. So if you haven't used Aurora Vision or monitoring is definitely a way to get more power production, monitor your system, and ensure you're getting what you're paying for when it comes to that install. With our Aurora Vision, you can monitor a whole site, whether it be commercial, utility, residential. You can have micros, string, a lot of graphs, a lot of reports you can print from there. We don't have time to go over all of that today, but definitely something to look into since not very many people in here have experience with Aurora Vision. So you have the local monitoring with the CDD and an integrated web server. So what it's going to give you is it's going to actually give you a web server, and it'll communicate with that CDD locally. And that's how we're going to actually configure the devices, which we'll go over here in a second. Question?
Does Aurora Vision come with the micro, or you have that a separate software you have to buy?
So Aurora Vision, it's a web-based program. You don't have to buy it. You just have to set up a user ID. When you purchase a data logger, which is a CDD, you get it with your 10-year warranty with the microinverter. So you get the monitoring as well. Correct. There's no fees for usage on that. After your warranty, I'm not sure how that works. You would have to talk to sales. I'm a technical guy. I don't know after the warranty period if there is a charge for the use of that system. But you do get 10 years of monitoring with the inverter and monitoring. So the concentrated data device overview. So it can monitor up to 30 microinverters. So 30, that is going to be your limitation. If you go to a site where you have over 30 microinverters, you will have to have another CDD. And the CDD also, because our inverters don't have LED indication of ground fault on the actual microinverter itself, it is required to have to actually be code compliant, because you have to have ground fault indications, and you also have to have a way to reset the ground fault. The only way to reset a ground fault on our microinverters is through the web portal using the CDD. So that's another thing. Some people ask, can I just buy the micros? You have to have the CDD, one, to configure them, and two, because to be compliant with ground fault. User-friendly plant configuration. So when you're setting this up, if you do have multiple CDDs, it's pretty easy. You can delete certain inverters from the CDD once they communicate with it. If you select certain CDDs and you acquire, if you acquire certain micros to a CDD, let's say you had that site with 32 microinverters, so you have 2 CDDs, put 16 on one, 16 on another. First CDD that you put on is going to find all of those inverters. You select which ones you want associated with that CDD. Once you acquire them, those ones won't show up when you pop the other CDD on. So you're not going to have that crosstalk or any sort of interference when it comes to those communications. So once they're committed to a CDD, they'll essentially just see those inverters and that CDD. Question?
So if you have 2 CDDs, let's say like 60 inverters, can you look at the total power of each inverter by all once, or do you have to look at it separately?
So as far as that goes, you would use the Aurora Vision or the web base, and you could look at the total production by coming from both of those CDDs. So you would be able to look at total production off of a plant. Does that answer your question? What's that? Yeah, if you have less than 30, you would only need one, right? I was given the example if you had 32, so you would split it into 16 and 16. So, does anybody have any other questions before we continue on? So this is just showing you the main components. You got your Wi-Fi antenna, status LED, radio antenna, the display, and the button pad that's very similar to most of our inverters. So a little bit of the stats on the communication device. We already discussed the limitation, that's 30. Another is going to be the max distance for communications. It's 165 feet. That's in free air. So another thing to consider on the design phase of these installations is going to definitely be what sort of obstructions do you have? Concrete walls, metal roofs. All that stuff is going to impact this radio frequency signal. So definitely part of the design is going to have to take into account the structure that you're installing these microinverters in. Another thing I'd like to point out is this enclosure is only NEMA 1, which means it's supposed to be indoors in a room somewhere. We like to recommend near your internet. It's got a sleek design, kind of looks like a router or a modem. So you can put it right next to your computer. It has that indications of any sorts of faults that you may have. One thing with that, you can move it around the house. So like I said, it has the wireless or wired communications to your actual internet router. So that's one thing that it doesn't necessarily have to go right next to your computer. Uses 485 or RS-485, and it uses Ethernet. So with that limitation on distance, one thing to get around that is you have an accessory that you can buy to extend that antenna, so you can wire that antenna actually outside or around that obstruction, or possibly if you're on a larger site, to where you can get those communications. And that's already available. They've already been testing that at a few sites. We also have the trunk cable extender coming soon. Right now you would have to, any gaps, you would install your own cable there. Chances are you might be saving money anyway using your own cable. And then you have unlock tools as well. So once you turn on this communication device, what it's going to do is it's going to start scanning for Wi-Fi signals, and it's going to locate the Wi-Fi signals in the area. Ideally, it would just find the homeowner's Wi-Fi. After that, it would give you a web server IP address. You're going to want to put that into your web browser. And what that's going to do is that's going to pull you up to the integrated web browser, which will actually get you into configuring these microinverters. It's first going to give you a password and username that is going to scare anybody who doesn't know what they're doing kind of out of there. The default is admin. So when you get in there to set everything up, just type in admin, and it'll let you log on and configure that. So this is what it looks like. You have a bunch of options up here for configuration, and we'll talk about a few of these as well. So after that, it's going to start scanning for some of these micros. We put 20 minutes plus or minus. We're looking at more like 5 or 10 for most installations. So as far as time to acquire most of these micros, you're not going to be sitting there for days on end trying to find every single micro. It's relatively quick. Click that Start Acquisition. What that's going to do is that's going to start populating all the micros it's communicating with. It's going to give you their serial number. It's going to give you their own MAC address and also their signal strength for each of the micros. After that, these micros aren't producing at all and can't produce until they've actually been configured to the country standard. So this country standard is going to set, the trip limits. It's going to set the frequency. It's going to set all your different voltage settings to match up with the grid. I think Hawaii alone has like 7 different options to choose from. So it's definitely one of those things that you're going to have to do that prior to these micros actually doing any sort of production. So if you don't configure them, they're not going to produce until this step is complete. Question?
You mentioned about the country that you have to configure it, right?
Correct.
So would this work with 220 volts, 60 cycles? That for a Philippine application?
I will have to get back to you on that one. I'll have to talk to the engineers. I know there's a lot of options under that drop-down menu. I would have to look into that specifically to get back to you. Definitely. Right after this, I'll take your card and I'll get you that information. So this, what you can look at, each of the micros, like I said, you can lay out the page to actually look like the installation. It'll show you their production. It'll show you their signal strength. It'll show you their average plant signal. Shows you the total energy. So this signal strength, what we've been seeing is it's one of those things that's very similar to your cell phone. Just because you're getting 1 bar doesn't mean you're not getting communications. It just means they're a little bit less reliable than if you had 4 bars. So what we like to talk about is anything less than 40%, you're going to want to try to boost that signal strength by moving the CDD or troubleshooting why you're having that signal issue. 40 to 70, you have pretty good communications, not too many issues. And then above 70%, obviously, you have pretty solid communications. So if you did have issues with signal strength, run the micro acquisition wizard. If you couldn't find some micros, you would move around the CDD to try to get those. It's going to ask you to move the CDD around, and then essentially you're going to do that until you acquire all of your micros, and then that's when you'll determine the location for that. So after that, you'll register the CDD on Aurora Vision on the web portal. And this is where you can actually see it on the web, maybe get it to go to their smartphone or whatever they want as far as that goes. You would put in some of the homeowner information, or they could put in a username and password. After that, you'll get a validation email. That validation email, they need to click on that within 5 days, or else they have to do that registration for Aurora Vision all over again. And then after that, you'll provide the site information, installer information, phone number, contact info. After that, you'll set up the site. You can associate that with a plant that's already on Aurora Vision or establish a plant by using that MAC address from the data logger. That MAC address will populate all the information from the microinverters that it's already communicated with. And then you'll get a registration complete email and a link to that Easy View page. And that's what it'll look like. You get a nice graph. You can get 7 days, 30 days, 365 days. It's pretty customizable. Get all the different modules. Once again, this can be set up to look like your actual installation. Those modules, I'm working on getting a different slide that actually shows the different shading as well. Because each of those panels, if one of them shaded or isn't producing, it'll actually get a darker color depending on the amount of production. So you can track that as well. Maybe a panel has been black for 2 or 3 days. You could definitely troubleshoot that down, whether it's a micro or an actual module issue. Other things, it's got some weather info and all sorts of good data that people like to see as far as what they're doing for the environment. So that's a micro summary: high performance, high reliability, a fast, easy installation. We do have, one of the things that we've been working on with all of our inverters, not just the micro, is a quick start guide. All these manuals are pretty thick, they're hard to read through. Quick start guide, it's kind of like installing a stereo. You're going to reference that because it'll get it up the first time you're working on it. So that's definitely what we've got with the micro. You go online, you can actually download that and use that quick start guide. It's pretty thorough and it'll help you out a lot, especially when it comes to the communication part of it. Does anybody have any questions about the micro? Question? I'm not sure the timeline on production and numbers of installs. Rob Robinson, you might be able to help me out with this one. Okay, so about 30,000 in the field. So you'd have to talk to your distributor. I don't have any pricing information. Question up front?
I missed, what's the warranty on that microinverter?
The warranty is 10-year warranty. Standard, just like our string inverters. Question?
So once you set it up, though, let's say you lose your internet connection, how standalone is it without internet?
Okay, as far as the data communications, the CDD will still talk to the micro even without internet connection. They're going to communicate to the CDD using radio frequency. So it's just like a regular data logger. Once internet communications come back up, assuming that data logger's had power the whole time, it'll backfeed that information for the time that you lost internet connection.
Okay, I mean, a lot of people that do solar, they're trying to get off the grid, so to speak, and their fear is, let's say internet goes away.
Right.
Flare or something, all your communications are out. There's no way to reset your GFI without going through the website, is that correct?
So you don't need to actually go through our website. You just need to go to the web portal, which is a local integrated web browser. So if your computer is locally to the CDD and the CDD's got power, it can communicate using that MAC address, or the MAC IP address that it gave you on installation. You use that, you can communicate with that CDD and you can reset that ground fault if you did have that indication. You obviously want to reset your ground fault or isolate that ground fault prior to that, but definitely. Question?
Off the grid, I know other manufacturers' microinverters don't work off.
Yeah, so like I said earlier on, ours are all grid ties, so yeah. Any other questions about the microinverter? All right, so I think that's about all the time we have. We'll go ahead and take a short break. Yeah, how much more time we got? 10 more minutes. All right, so we're going to hit the single-phase string then.
One more question.
Oh, question about the mic.
Are you competitive with Enphase?
As far as,
Cost of the module?
yeah, once again, I don't have any pricing information. What I do here is we are competitive, so to answer your question, from what I've heard, we are. You would have to definitely make your own.
They're larger, I mean, they're 250 watt and 300 watt microinverters compared to a 215 watt, which is in phase. So per unit, ours are going to be more expensive, but cost per watt, they're just larger. They're larger micros, they handle larger panels.
So we'll touch on these single-phase string inverters. You'll notice a lot of this stuff is going to be very similar. Our microinverter, single maximum power point tracking. Same way with our Uno, this smaller isolated unit, one of our newer, sleeker designs. Then you got your transformerless. You got your 3, 3.6, 4.2, all the way up to 5 and 6K for the string inverters. So for the single phase, this is our Uno specifications. You can look at all these online. Some of the ones that I'm going to highlight is the full power Mppt range, 170 all the way up to 470, and then 205 up to 470 on the 2.5. Other things I'm going to point out is, once again, we're NEMA 4X rated across the board. Our efficiencies at the top of the line. Natural convection, we don't require cooling fans. So we do have fans, they're just recirculating fans. These enclosures are true 4X enclosures. We can't pull air in from the outside. So they just recirculate the air. We've never had an inverter return due to high temperature or temperature-related issues. So that's definitely a huge plus. Higher efficiency, fast installation. We'll go over a bunch of that. Reliable design. So this new die-cast aluminum design is very sleek. Some of our PVI series that we'll look at a little bit later with the cooling fins on the outside, some of those are pretty sharp. And also, we've had some complaints on look. People want the stainless steel, the sleek look. So that's what we're definitely going to. This is just showing you the different layers with that sleek design, how it actually accomplishes that convection cooling. We're going to cruise through some of this due to time constraints. Quick installation. So some of our PVI series had a little wobble because they just had a straight bracket. They didn't have the T bracket. This T bracket mitigates that wobble and helps out with that. Also, we've incorporated captive screws. No longer are you losing hardware or needing to track down some screws. Those screws are just captive. They stay in the cover themselves. Another thing is the cover itself just moves up out of the way of where you need to perform your wiring connections. That way you don't lay down the cover and get it all scratched up, because then the homeowner doesn't get the brand new inverter that they wanted because you scratched the cover, right? So that helps out with that as well. This is just showing you that the switch box can be mounted separately. Some of the different components. Our inverters can be field configured for negatively or positively grounded arrays. You have your different communications board for that Aurora Vision and the monitoring solutions that I briefly discussed earlier. The new graphic display. So our old display was 2 lines, digital, not necessarily the most informative. You had to scroll through a bunch of options and menus. Didn't really light up. Wasn't that customer friendly, I would say. As far as this design, it's got a nice little graph on the front. It shows you the different, shows you your grid connection, shows you your production, all sorts of different things. Also, a different thing about these newer inverters is they're actually powered from the AC side as well when it comes to the display. So in the middle of the night, 10 o'clock, somebody wants to go down there and look at their inverter, they can actually do that. With some of our older models, you can't do that. Oh, why is my inverter off? It needs DC power for our other models, so that's another thing. With these, you have your regular power, alarm, and ground fault indication lights, as well as our menu navigation buttons. Just showing you, once again, we like to brag about our DC wide input range as far as how much energy harvest we can provide. All the way down to less than 100 volts DC, this 2.0 will continue to produce. Electrolytic free capacitors, I've talked about these, how they eliminate or at least prevent damage to the inverter on input surges. So on these string inverters, you have an installation that you wire improperly. You could blow an inverter and blow the capacitors in some of our competitors, whereas with ours, not going to happen. These look like 55-gallon drums. They're actually really small. They're on the circuit boards, so just to give you a heads up. They're not very big. Our weight for our inverters is very small. Talking about the field configurations for our negatively and positively grounded arrays. Pretty simple configurations. Move a couple of wires and you're done. As far as the installation, obviously you want to pay attention to your clearances. So the PVI series, this is what most people, if you have installed our products, are more familiar with when it comes to single-phase string. Our older style, our transformerless, could be identified pretty easily and quickly just by looking at the switch box, where the switch box was at. However, the newer design, all of our switches are going to the front of these switch boxes. And a lot of that's come from feedback from the customers. We take all the feedback that we get through tech calls, through training events, and we definitely try to implement them into our products. That's why they're constantly changing. You won't see very similar products year in and year out. They are constantly changing. Here's a display, a little bit older look. NEMA 4X enclosure. So this is where we get into dual MPPTs. Is anybody in here actually familiar with what dual MPPT or dual maximum power point tracking is? So what that is this essentially gives you two inverters in one. So let's say you have a 4.2, you essentially have 2.1 or any sort of mathematical combination to get to that. You essentially have two inverters. So if you have arrays at different angles, different tilts, different size strings, different modules, you're not going to lose that power production due to that D rate that could possibly happen on just having a single MPPT inverter. I think I got a slide on that a little bit later. This is just highlighting our CEC efficiency, our wide DC operating window. Once again, those are two things we like to brag about all the time. Two MPPTs, a lot of the industry is following us with that and coming out with new products to match that. NEMA 4X, and once again, natural cooling convection. We don't need cooling fans. This is just showing you another similar product, just giving you the same thing. We lead the industry. Product change, I talked about the switch box design. Another thing that we're changing is the screw terminals. We're going to pressure terminal blocks. One, how many installers are taking torque wrenches with them? Also, you're not going back year in and year out to actually check the torques on these. Another thing is we got a lot of feedback, and the two guys I work with in training, they said, oh man, pressure terminal blocks, we don't like these. These break. You know, they were totally against it. They've been working with these, very robust. We usually bring one with for training to pass it around. We haven't seen these things break. These are awesome. Real good design. Maximize that connection, and definitely the reliability of the product has gone up because of that. It also eliminates that over-torquing capabilities. So the string sizing, right? So I talked about the strings don't necessarily have to be equal. With most inverters, they recommend you to have strings that are equal. So let's say you installed 10 panels and maybe later on they wanted 6 or 7 panels. You get a discount price. They're different modules. On a regular system, you would lose a lot of production from that system with only having one MPPT. However, with the Power 1 inverters with 2 MPPTs, utilizing that, you actually maximize both of those strings. Another thing is different tilts or different directions, right? So during the morning, MPPT 1 might be getting most of the the sun, so it'll maximize that IV curve, and you'll actually get that maximum power point from Mppt 1. Mppt 2 in the afternoon will have that higher curve. So they essentially have two independent curves, but yet work as a team for that output. So instead of limiting each other, they're helping each other and getting that maximum energy harvest. Question in the back. So the smallest inverter size that we have is a 3.0. So, question?
So do you wire each of those strings to a different terminal to get the two different
Yep, there's
MPPTs, or do they just automatically do that?
so there's different inputs, and we'll touch on that real quickly on how to wire those for dual or independent. So you can use our inverters utilizing just one Mppt if that's what you wanted to do. We don't really see a reason why you would want to, but you can. Here's one just showing the different angles and number of modules as well. Question back there? Yep.
Okay, does this need an optimizer like the Solar Edge, or it's just like straight?
Nope, it's straight to the inverter, no optimizer. If you just use one side, you still get maximum use out of that inverter. All it's doing is it's just using one algorithm vice two algorithms.
You're gonna jump over the two MPPTs.
It's going to utilize the whole inverter either way.
Before we wrap up, I just wanted to make sure you had some time to go over the string sizing tool that you guys have online. I don't know if you have any slides built into your presentation. I know on in the booklet there is
Okay, definitely.
information on it, but we're going to,
All right, cool. Yeah, I'll get to it real quick. You can go squeeze to it real quick. So the string sizing tool, I could pull that up and we can look at that.
if you just want to go through the slides, that's fine. Maybe later today, lunch, something to go through a scenario.
Okay.
But just, just to kind of do a brief overview of what that would be.
Okay, so the string sizing tool, we can all take a break later and look at the string sizing tool online. But what it'll do is it'll allow you to select an inverter and some panels, set up your array, the location, and it'll actually give you single, dual Mppt options, and it'll let you know as far as designer notes whether you're overrating the inverter, underrating the inverter, whether you need to lower the V-start, right? Our V-start on our inverters on the DC side is 200 volts. You can lower that down all the way to 120 volts if you do have a smaller system to start up those inverters. So we'll cover that a little bit later. What's that?
Lower that, then you high voltage instead of same on the window?
Correct. So this is just showing mounting the inverters. Once again, you'll want to pay attention to clearances. Our older mounting brackets were just the single. Once again, the electrolytic free capacitors. So the dual Mppt wiring, so if you were going to utilize both Mppts and maximize that energy harvest from different arrays or strings, I should say, then you would wire them up independently, and you'd want to switch that input mode switch to independent. And what that's going to do is if you don't do that, then on startup, that inverter, if the wiring doesn't match that input mode switch, it'll give you an E013 wrong mode. So pretty easy fix on startup depending on what you're doing. If you are just going to utilize one Mppt, you would install these jumpers. They come with the inverter in a package in the box. And you're going to want to switch that input mode switch to parallel. So that's when you're going to parallel those inputs, and like Rob already discussed, what that's going to do is it's just going to parallel those inputs and still utilize the entire inverter.
What's the advantage of doing that?
So we haven't seen any advantage to using just one Mppt. The reason why you might want to do that is if you had a smaller installation, depending on your voltages and currents. Maybe if you bought a larger inverter for a system, not necessarily all the panels at once, you were going to come back and possibly raise the number of panels on that system, then you would utilize 2 Mpts. Really depends. So this is just showing you the wiring cabinets, how they interface as far as this is where you would do your jumper cables as far as parallel or independent. Communications and your AC connections. That's where you would land it in the switch box. So our isolated units, you got to change the grid standard using dials. Obviously, depending on your grid, would depend on how you would wire the AC portion. We do have voltages that can allow these single-phase inverters to feed into a 3-phase, utilizing multiple inverters. So, if you want to change the V-grid setting or the V-start setting, you would go through the menu options, utilizing the buttons. Scroll down to settings. It's going to ask you for a password. That's kind of to scare any button pushers and homeowners out of there. Password just 0000. After that, you'll go down, scroll down to set V-grid or set V-start. And then it'll give you some options. So set V-grid, it'll give you 208, 240, 277. Select it, hit confirm, and then that's how you set the grid settings. So if you get wrong, if you get grid fail or grid out of range, chances are you need to set that V-grid. If you wanted to set the V-start, like I said, on a smaller install, maybe you wanted it to actually start at 9 in the morning, vice around lunchtime, you could lower that V-start. Default is 200. You could lower it all the way down to 120 volts DC by going into set V-start, and you can set it to whatever you want. And the string sizing tool helps with making recommendations on what to set V-start at. And that's real quick. I took a little bit more time on the micro. We kind of cruised through the single-phase string. If you have any questions, definitely get with me right after this or during some of the breaks, and we'll discuss it. Any other questions?
So you mentioned transformerless inverters. Are they all transformerless, or some are and some aren't?
So right now we actually have a 3.8 and the 4.2 are isolated. Same way with the Uno 2.0 and the 2.5. Those are isolated units. Those have the transformers in them. The rest of our models are transformerless. Like the rest of the industry, we are going to transformerless as far as those models. I believe those models are being discontinued. So that's another thing that we like to pride ourselves on, is kind of being the innovator as far as that transformerless technology.
You know, in your package here, there's a list of all the inverters that goes with transformers. It's actually 3.6. They're actually isolated. We're actually facing with the house, which we 3.8 into the TL. It's just a lighter, more efficient, less expensive unit that are all around. The isolated units were really built to accommodate either just break the grass transformers. So, but just to make one more point, this dual Mppt feature is what really has built our one to the second largest company. That's a very valuable feature. A lot of installers will go out or companies or they've been on Google Earth, see what they can give us a group. They send their sell a system, go out and get out there, they don't have the space. And you get strings, so they'll scale stuff back or switch to a micro or something. And this, you know, basically gets more power. Allows you to sell more stuff.
What's the advantage of this over microinverter? Cost?
So you definitely have to look at the size of the system, and there's a certain break where cost is actually more effective to go with a string inverter vice a micro. I'm sure Rexel would have a little bit data to help make you decide one way or another. Question again?
For a system that isn't grid tied, I know some single phase inverters or single inverters have something they can plug in to work with the batteries to convert to a battery backup system.
So ours are just grid tie inverters, so we don't have options for that.
Inverter as an AC coupled system. AC coupled system is what you're speaking of, and you would use a separate inverter along with the grid-tied inverter to provide that capability if that's what the homeowner's looking for. And we can get into that in a little more detail offline, but in regards to staying on track, you know, I really appreciate your presentation.
Definitely.
And, you know, I know you'll be around to answer questions for people, you know.
Sounds
after.
great. Any other questions? We're going to go ahead and move on. Thank you guys all for all your questions and participation.
Great
And
job.
thanks again.
Yeah, thank you. Thank you.